Hello algebra students, and welcome back to another video lesson as we continue the exploration of graphing quadratic equations. Today we're going to begin the exploration of standard form, which is y equals ax squared plus bx plus c. So we're going to begin exploring the role of the a value, the b value, the c value. We already know two of them. And then we're also going to start to identify the characteristics of a graph of standard form and what that looks like. So please make sure you're taking notes. We are going to have a test coming up in the next week. So you'll want to make sure that you can explain and understand this information. Got a couple of true and false statements that I'd like you to answer as we go along based on what we've discovered so far. First one, true or false? The parabola y equals 4x squared opens down. Well, hopefully you said that's false. The a value is 4, and when the a value is positive, this would open, not cup, but up. Up. When the a value is positive, it's going to open up. Number 2, true or false? All parabolas that open up have a maximum value. If a parabola opens up, does it have a max or a highest value? So here's a parabola that opens up. And so these lines are going to continue to go on and on forever going up. So does it have a max or a highest value? This is also false. If a parabola opens up, this bottom point right down here, we don't call it a max, we call it a minimum. So any parabola that opens up will have a minimum value because it's got a lowest point. Conversely, if it were to have opened down, then it has a highest point right here, but it doesn't have a low. Number 3. -3 to the second power is 9. Well, hopefully you wrote that's true. We spent a little time practicing this in our live sessions. Remember that -3 squared means -3 times -3, which is indeed a positive 9. Be careful how you plug that in to a calculator. True or false? A parabola with a value of 7 is steeper, or what we might call narrower, in comparison to a parabola with a value of 2. This is true. As those numbers for a, as the a value gets further away from 0, it's going to get steeper or narrower, right? If this is 0, 0, it's going to start to grow really, really fast in both directions. The further that a value gets away from 7, or from 0. Last one, true or false? Every parabola has a vertex of 0, 0. This is false. A lot of them might have a vertex of 0, 0, but as we explored with the c value yesterday, not every parabola has a vertex of 0, 0. We're going to learn a lot about how they move or shift on our coordinate plane. Right? So that's the basis of what we started with in graphing these parabolas. You do need to make sure you know that standard form is this equation. Y equals ax squared plus bx plus c. And that is what we call standard form. And we're trying to understand what do all of the a, the b, and the c values do to our graphs of that parabola. So I'm going to hop over to a minute for a minute on Desmos, and we're going to explore the graph of ax to the second plus bx plus c. So let me just get rid of these for a moment. So you can see I've got y equals ax to the second plus bx plus c. And you've got this little option here to add sliders, meaning I can adjust some of these values for a and c. And so we're going to start out with the standard one where we have a is 1, y equals ax squared. Watch what happens again as we adjust this c value. This was from yesterday. If I move the c value to, say, 3 or close to 3, notice how the vertex moved up, right? It moved up. If I move this slider and say I want my C value to be negative, all of a sudden it slides back down. So the C value takes and moves this vertex up and down. All right, let's set that back to 0. The A value tells us if it opens up or down. So positive 1 is up. If I did negative 3 for a slider, it opens back down. Right? If I do a positive 1, it's narrow, or it's standard. But if I try and do 10, it gets much steeper or narrower. So what do we think the B value is going to do? Well, if I play with this slider and change the B value, look at what happens. It moves the vertex off the y-axis. It moves it left and right, and honestly, it moves it up and down a little bit too. Right? But the main idea is that it moved it. If it was a positive number, it's moving it left. If I put in there a negative number, notice how it started moving it to the right. Now, we're going to learn about exactly how to calculate that in another section, but the idea here is that this B value all of a sudden takes our vertex and shifts that vertex left and right. All right, so that's the main idea behind this B values, moving it left and right. I can move it up and down with the C value, but I could also move it left and right with the B. So don't be afraid to play around with it and see what happens, okay? Here's what's happening in summary, right? This is a good probably spot to pause and make sure that you have these notes. A value, if it's positive, it opens up. If it's negative, it opens down. If it's closer to 0, it gets wider. If it's further away from 0, it gets narrower. So that's our A value. Our C value, again, it is the y-intercept. It tells us exactly where the y-intercept is. Tells us where to cross that y-axis. The B value is going to start to shift the graph so that it's no longer on the y-axis. It's no longer exactly in that center y equals line, y-axis. All right, now I want to explore a little bit of these graphs to try and understand some of the concepts that are happening from standard form. We don't have the standard form, but what we do have is the graph. What is the vertex of this graph? Well, you'll notice that right here is where our vertex sits. The graph starts to go up, or down, and then up. So what is that coordinate? -3, -1. Vertex. Now, the axis of symmetry is the vertical line that goes right through it. Right? Everything has to be equally spaced on the left and right side of that line. So the axis of symmetry will always be x equals, and it has to go through the x coordinate, in this case, -3. The y-intercept. Where does our graph cross the y-axis? If I go and grab a red marker and look for the y-axis, here is that point that our graph, our parabola, crosses the y, and they tell us that the y-intercept, or they label the point for us as 0, 8. X-intercepts. Where does our graph cross the x-axis? Well, notice it touches the x-axis twice. One at -4, 0, and another one at 2, 0. So we do need to list both of those x-intercepts. Does the graph open up or down? Hopefully we see that it opens up. And because it's opening up, what would we call this very bottom point? That is a minimum. It's the lowest point on this graph. Domain. Which variable describes domain? It's the x variable. So we're looking at the x. How does our blue line, the parabola, act on the graph going on the x? Well, remember, if I have an arrow on the end of it, it's going to keep going up and to the left forever. It's going to keep going up and to the right forever. So the domain for a parabola is what we call all real numbers. It's going to keep going on and on forever. All, this is the symbol for real, all real numbers. all real. The range describes the behavior on the y. Notice, it doesn't go past this point right here at -1, but it continues to get higher and higher and higher forever. So we say that the range, our y values, because we're describing it going up and down, that the y values have to be greater than or equal to the lowest point that they touch is at -1, which coincides with our vertex. So those are some characteristics that we should be able to identify if we're just specifically given a graph. Now, what happens if we're given the information in a table? How do we identify certain things in a table? Well, you might want to just make a quick little sketch of the graph, right? -3, -2, -1, 0, 1, 2, and 3. -3 is way up here at 12. -2 comes down to -7. -1 to 4. 0 comes here to 3. 1 comes back up to 4. 2 back up to 7. 3 back up to 12. Right? So I don't even have those exact values on my graph, but I know that they're over here. So does this open up or down? Well, it's going to open up. Why is it opening up? Because the numbers, if we look from here, they're going down to 3, and all of a sudden we hit 3, and then we go back up. There is our vertex, because that's where this shift from down to back up happens. So the vertex is at 0, 3. And again, if you look at the graph, right here is where it happened. What's the axis of symmetry? X equals 0. It's got to go through the x coordinate. What's the y-intercept? Well, the graph touches right there. My picture is probably a little bit inaccurate, but it's at the point 0, 3. It's the same as the vertex, ironically. What are the x-intercepts? Does this graph cross the x-axis? No. So we say there are none. No x-intercepts. None. Because it doesn't cross the x-axis. And that will happen. Do we have a max or a minimum value? Well, again, because it opens up, this would be a lowest value or a minimum. So we would say min. What's the domain? Domain, again, is all real numbers. Any domain for a parabola is going to be all real numbers because it goes left and right forever and ever. But what's the range? Well, in this case, all of the y values are going to keep going up from there, right? What did we say the value was here at our vertex? 3. So all of our y values have to be greater than or equal to 3. Now, we went through a lot of these characteristics kind of quickly. It might be beneficial to watch the video again, but make sure that you take notes. We are going to explore a little bit of this again, a little bit more tomorrow in another video. I'm going to ask you to answer some questions today, and they're going to look like this inside of Classroom. That'll be your online submission for today, is to be able to answer those 4 questions. If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.